Okay, so thank you all for joining. And yeah, this is yet another webinar, and thank you all again. So in today's webinar, we'll be talking more about Kafka and Spark, and like what is it in general about the real-time data streaming concepts, and what are the technologies that have been evolving. So basically, if we take in today's like very fast-paced digital ecosystem, this the need of real-time data has been like booming. Like there's been always like asks from customers and specific use cases coming up where they need to take some actionable insights on like very fraction seconds. And actually, as and when organizations try to process this information, so it's good to have kind of this all mechanisms, streaming mechanisms in place so that they are ready for this kind of change that's happening, so that they can take these business decisions in in a real time fashion. Speaking of which, there are two prominent technologies that have been emerged, and like this one is Apache Kafka, and the other one is Spark. So before we proceed, let's introduce ourselves. Uh, Myself, Deepan, I'm Senior Product Manager here at DoubleCloud, and I'm responsible for the product and releases in accordance with the platform itself. And Andre.
And my name is Andrei. I'm an engineering lead. I'm responsible for our ingestion service called Transfer, and I have a huge expertise in model and streaming technologies. So I'm here on your service.
Yeah, and last but not least, DoubleCloud. So DoubleCloud is a platform to build end-to-end managed data stack on proven open source technologies. So we'll talk about DoubleCloud bit on a later stage, but let's move ahead. So real-time streaming. So as we saw, like real-time analytics are like game changer for businesses. So they allow like to optimize operations on fly, and there are different couple of use cases, like whether it be like checking social media updates, online purchases, inventory updates, logging mechanism. And there's also like bunch of a whole world of IoT devices, which is just sending information in a faster and real-time fashion. So the driving force behind all this seamless experience is nothing but real-time data streaming a platform. So having said that, yeah, and there are also other couple of use cases more on like anomaly detections and so couple of other things. And so why are we talking about now in the real-time streaming? Yeah, there are two prominent technologies like what we saw earlier, like Kafka and Spark. So they have been both gaining some adoption, and also in like so there are different purposes each of them have, and different scenarios where each of them like play a very good role and other one doesn't. So let's understand the strengths, weaknesses, and couple of optimal use cases, and which is crucial for making the decision to choose the right technologies. Andre, what's your thought?
Yeah, I'm sorry that real-time streaming right nowadays is a really hot topics, mostly because the amount of data in the world become just growing and growing again and again, and rely on the classical approach, which is a batch analysis, is sometimes is not yet efficient. It's prominent, it's working, but in some cases it's not get enough speed of a data, and therefore the decisions that made on top of this data may be delayed. That's why real-time streaming sometimes is a crucial part. For the for the some cases, it's even a most important things. For example, analysis for IoT or social media interactions, because this is done in right here, right now. And once this data, I would say, stalled for hour, it's become useless. That's why streaming for them is quite essential.
Yeah, speaking of technologies, Kafka and Spark, let's move on and let's explore deep on that. So, having said that, and Kafka is more like a messaging system. It's an event streaming platform that kind of empowers organizations to create and manage and harness this real-time streaming. So there are a couple of abilities or benefits, like it's built to handle massive data flow. Particularly, it's well suited for high demand situations such as like logs, telemetry data, or social media, and let alone like it has its underlying architecture. It's also built in a way like it's also fault tolerant, so that there are like a couple of nodes and services that are spread across. Right? And what about scalability, Android?
Yeah, the beauty things in the Kafka itself is that it's quite simple system in terms of scalability. It's really easy to scale because you have very nice granular scaling factor. It's like a topic, and inside of a topic you have groups like consumer groups or partitions for writing. On those things are easily horizontal scaling. And for Kafka, it's not a big deal to scale to enormously huge clusters. And meanwhile, it can be done. It can be working with a rather small one, like on a couple machines with a couple CPUs in it. That's the beauty of a Kafka. It's itself is not a platform. It's not ready to use a platform, but it's very good foundation for building the platform on your own. Because the Kafka is a the very nice building blocks that allow you to at least start streaming processing, like store the stream somewhere and do something on it. But meanwhile, Kafka is a very old product. In these cases, these products already have a lot of exploitation expertise, how it works in a world, and a lot of tooling about build it on top of Kafka, which helps you to actually do some meaningful business work on this data that stores in Kafka. For example, Kafka SQL is a great tool for that, or maybe some third-party components that just read the streams and do something with it. So yeah, Kafka is a great foundational tool. I would say it's not like a platform's tool, but it's just a tool when you can, on top of which you can build a very nice streaming platform for yourself.
Yeah, I think what you said is also true. Like they have like very huge community. It's been there for like ages, and they have very good ecosystem of integration capabilities, right? Like they have like sync connectors and Kafka Connect and a lot of the toolings which enriches the existing core functionality of the Kafka
Yeah,
itself.
and even you can write on your own. It's not so complicated. But even if you don't want to write anything on your own, you have a lot of already implemented open source technologies that build on top of Kafka.
Yeah, and the fact that in the backend we ourselves are using Kafka for processing all the backend needs and in terms of queue. Correct me if I'm wrong, Andre.
Yeah, yeah.
Yeah. Okay. So let's proceed. So next one is more on the Spark. So Spark is more like a powerhouse for data processing engine that can kind of like transform the way how we analyze and we're working with data. So it's mostly like an because the popularity it gained, it has its tremendous capabilities of processing like tremendous workloads in terms of machine learning or be it a transformation or also like some complex analytical use cases. So they are beautiful. It's a beautiful piece of tech, and it has a lot of capabilities. I would also say it's kind of like a Spark is like a beast. So
Yeah,
as you
yeah.
can see in this image, there's a lot of possibilities that you can do, right, Andre?
Yeah, yeah, that's right. That on controversial with the Kafka, Spark is a in a different league, I would say.
Yeah,
It's not a tool. It's even not a toolkit. It's a whole framework or a platform itself. It's very powerful software that allow you to do almost anything. But with this flexibility and versatility, you receive as a drawback an extreme complexity. That stuff is complex. To efficiently handle it and working with it, you have to have some extensive expertise, and you definitely will need to write some code here because Spark is basically an execution runtime or maybe framework on top of which you build your application. If you have to take a look on a Kafka on a other hand, it's more like a tool that you can use as a tool with third-party components and build your platform with these analytical building blocks. In a Spark, it's not so easy. You usually need more precise tuning, even some application writing for Spark. And also Spark cluster is really harder to maintained because they usually bigger, and the minimal version of us work on production workload Spark cluster would be not so tiny as a work in Kafka. And also one more important thing, that actually usually these two things come in pair. When you have some streaming in a Kafka and you analyze it for quite a long time, and then you realize that platform become more and more complex, and you are ready for next more advanced scenarios, then usually in this time the Sparks come to your organization, because Spark require for you at least some matureness of your data culture. The amount of data should be decent, as understanding of this data should be already in place, and this Spark stuff are usually built connected with the Kafka, the existing one or new ones, and this Kafka usually act as a entry point for Spark ecosystem. You write something in a Kafka, and then Spark start to do something we need. It can be ingest something into a graph processing, maybe in data lakes, maybe do some machine learning calculation, maybe machine learning model adjustments, and maybe building flat tables, complex one for dashboard analysis.
Yeah, so what you said is true. So basically, we cannot just compare like Kafka to Spark. It's not like apples to apples comparison here. But what we're trying to say is more like each of these technologies can leverage another one so that they both go very hand in hand. But it's good to know like in which specific use cases we can leverage and use each one of them. It's not necessary that maybe for a tiniest workload or use case you need not have like a Spark, such a huge cluster. So I think that's what we're going to touch base on the next slide on when to choose what. So basically more like there are different scenarios like for example like real-time data streaming messaging or complex data processing. So in which of the scenarios we need to choose, let's say either one of them. Like say choosing Kafka when it's real time are like very paramount, and these are like very ideal situations where data needs to be ingested and processed in more like a distributed real time. So because of its beautiful event-driven architecture, so there are a lot mechanisms where you can just that if the use case requires something like a publish and subscribe mechanism, so you can definitely rely on Kafka in terms of because it ensures like the messages are delivered in a reliable way and there are multiple subscribers that's connected to it.
Yeah, and one more thing that you need to know about this comparison: when you have a real-time data streaming, in some cases, data delay can be crucial for you. In this case, a Kafka streaming would be a better choice than Spark, even if you have Spark in place already, because Spark jobs usually take some time to run to start, and this may introduce unnecessary delay in your data delivery in a matter of seconds. You need to understand the seconds in some cases are crucial. In this case, Kafka streams are far better option. But if you don't have such strict requirement, both of tools are good to go. But Kafka is easier to acquire if you don't have anything, and Spark is more powerful in this case.
Yeah, and speaking of which, the next point is the complex data processing, right? So let's say there is a definite need of complex data computation, let's say transformation, aggregation, so all these capabilities. So Spark is like the best player to that you can pick from, and because it utilizes its in-memory processing to perform all these operations with its high speed and efficiency. So having said that, Kafka primarily focus on like messaging or data streaming to just ingest, and it's not designed for this kind of huge complex data computational problems, right?
One more thing I want to add here, that when we talk about data processing, we usually talk about some modification in the data, and even slight modification of the data can be showed as a SQL query, simple SQL query. And for a Kafka, it's usually not so easy to just apply SQL query because it's not a SQL database itself. There is some tools that allow you to emulate the SQL engine, like a Kafka SQL itself, but those tools usually fairly limited in terms of capabilities. And Spark here is a more powerful stuff. They usually allow you to do a much more powerful SQL queries, SQL computation, and this actually allow you to write your analytical processing in the same way as you done your batch processing, streaming processing, and the batch processing in the same way, and that's actual main profit of actual having a Spark, because you can at least try to unify your data processing in terms of batch processing and stream processing. For Kafka, you usually have just one aspect of it, just streaming, and usually you don't have a very powerful SQL engine under the hood. So you should either write your code in the pure Java or use some third-party libraries like Kafka SQL with limited SQL capabilities. For some cases, this SQL capabilities is more than enough, like a simple transformation, but making a join between two streams, it's become a bit messy. And in this case, you have to need to think about a lot of complex stuff like windowing, which is a technique how to join two separate streams on which window of data it would be applies. In terms of Kafka, it should be done more or less manually. In terms of Spark, it can be hidden under the hood.
Yeah. Yeah, that's completely agree, because it's primarily on it's just feeds data. So that's our next use case, right? Mostly on machine learning. So I think Spark is again going to be the winner here, because it has its own machine learning libraries and classification, regression, all these kind of capabilities are mostly possible in Spark. And because it's basically leverages its in-memory computation, let's say for quicker model training and like iterative processing and stuff like that. But whereas on the other side, Kafka, it still goes hand in hand. But let's say it just helps to feed these machine learning pipelines and not really process them or to build some models out of it.
Yeah, I would say that in a Spark, it's much easier to integrate some machine learning capabilities, so like adjustment of a model, like usage of existing model, etc. For Kafka, you can actually do the very same thing, but you will need to write some code for this. There is no like very good and versatile tools for integration your machine learning ecosystem into Kafka world. You should write it on your own. In a Spark, on a controversial, it's already there. You don't need to do anything. You just need a Spark, and then just configure your machine learning library, which is already there. There is a lot of different machine learning libraries in the Spark ecosystem.
Yeah, I think the most of the points what we see, it seems to be like Spark seems to be like a like a winner, but it depends on use case that we'll touch base on later. Like for example, for batch processing and all, like Kafka, it's really not really useful for batch processing. It's mostly like it just keeps sending messages in real time function.
We need to understand that Kafka, it's not, again, apples and apples. I would say that it's evolving structure. Kafka itself has some different pros against Spark in terms of messaging and streaming, especially if you have a strict requirements in the data delay. If it's a matter of milliseconds, then Spark will not help you, because Spark sometimes restarts your jobs, and jobs can start for sometimes it's a matter of a seconds, even maybe a tenth of seconds, and this will add an unnecessary delay for your data delivery. In Kafka, there is no such things at all. But in a controversy, Spark is much more powerful tool. It comes with a cost, like with a steep learning curve. You need to learn a lot about Spark, ecosystem of Spark, libraries of Spark, the patterns, how to use Spark. Exploitation of a Spark cluster is also a very big deal. So this stuff is actually much more complex in terms of development efforts. But if it gives you a lot more powerful tools. On the controversy, Kafka is a very simple tool. It's easy to use, easy to acquire. You can also do almost very things with a Kafka, just like with a Spark streaming, but you need to do this with a less versatile toolkit. You still can do these things, but you need to do it a bit differently. In some cases, it can be even less complex, but overall, Kafka streams usually time to acquire and start exploiting in the production much less than in a Spark.
Yeah, let's say in conclusion, like both those tools serve distinct purposes in the data processing landscape. Like opting out for Spark is like when you want to focus on complex data processing, machine learning, advanced analytics, and let's say you want to graph needs and also batch processing. On the other hand, like if you want to use for Kafka, it's mostly on like real-time data messaging, and also like if you're going for like an real-time event-driven kind of architecture. So having said that, so now that we have seen like how the data has been real time streaming, it's an ingestion, but ultimately there has to be some place where you can store this data, right? Which is coming in like just flowing in real time fashion. So what are the technologies or things that we have? So having said that, so I'd like to introduce ClickHouse. Or ClickHouse is mostly like a fast analytical data store. It's very crucial in terms of, especially in terms of real time streaming. So let's say you wanted to process all this data that's coming from, let's say, all the real time data streams, Kafka, whatever, and then you can just put it in, and then because the whole notion of real time, it's like getting insight very faster, right? So
Yeah,
you can use
it's
the
a crucial thing.
technologies. Yeah. So you can use the technologies to process the data, but ultimately you need something to query the data out of
Yeah,
it. I mean,
the end goal of all the streaming processing is to put the data in the right form, in the right place. If you have, for example, a stream of events from your devices, for example, bikes in the city, they send you some signals and you want to analyze the signals as fast as possible. That's the Kafka shines really best. You just put everything in Kafka, process a little bit, add some unnecessary information like GOP, location, maybe some data cleanness, etc. And then you put it in some place that should act as a real-time platform. In some cases, you can just put it, for example, in S3, maybe in the Hadoop, something like this. But such data warehouses usually have with slow query performance because they not designed to do so. They designed to store this data, not query it in a real-time fashion. If you put this in some real-time analytical databases like a ClickHouse, you can just store it very fastly because ingestion speed is high and query them in real time. So in a matter of milliseconds, not of a matter in a seconds. As an example of this IoT devices storing in a Kafka and then in a ClickHouse, usually the signal from a device in a perfect good condition to an actual dashboard when you can see this device online can be limited to maybe a matter of tens of milliseconds. In this pipeline are not controversial. If you use Spark streaming and a Hadoop here, you will have 1 or 2 seconds of ingestion delay of Spark streaming for job setup, for some calculation, for some job teardown, etc. This will give you 1 or 2 seconds, usually extra delay, and then in a Hadoop, query such data will also give you a couple seconds of a delay, and so end-to-end delay between event on actual ground to the dashboard will be a couple seconds, maybe tens of seconds, in a worst case scenario, even a minute. So if you have a crucial requirements for data freshness, then a pair of Kafka plus ClickHouse can act really well here.
and also like ClickHouse has its inbuilt capabilities of its integration, right? So it need not be like someone has to set this up manually to make this whole end-to-end thing running. Right.
Yeah,
Speaking of
yeah.
which, do you have some customer use cases that you like to share, Andre?
Yep, we have several use cases when the Kafka streams shines best and Apache Spark streams shines best. In terms of Kafka, the main thing that is actually building this Kafka as a platform itself, it's a real-time messaging. So if you have some stream of events, stream of messages that comes from different sources, and you need to analyze them, as for example, IoT devices in a city that send some information in the cloud. This is actually Kafka best use case. You can do a simple transformation on top of this data, aggregate it, put it in some real-time analytical warehouse, such as a ClickHouse, and build your application on top of it. You can easily query this data in real time for fresh data or ad hoc queries for long-term data. And this in combination with a real-time data warehouse shines the most. Also, one thing that is Kafka really good with, we have some customers that use the Kafka as a message broker. It's a bit different approach. We don't say about some actual data movements. We say in a Kafka as a more technical purpose here. It's for messaging, message exchanges. So one service, we have an application which is designed as a microservice application, for example, and each service communicates with each other somehow. And this is usually done via some message broker. Some application put message in this message broker, another application reads this message from a message broker, and that's how they communicate. In this case, Kafka also finds a very sweet spot. We can do also in such of architecture, we can utilize both these Kafka capabilities for message exchange and for later analysis, because in our case, we have a customer that actually build such exchange on top of message bus, which is a Kafka, and then start to analyze these messages and build a whole analytical workload on those messages, because they already have all necessary information. We just need to deliver it somewhere and start analyze this data that we exchange, these messages that we exchange, events, how would say. In this case, this architecture of applications we usually called event-driven architecture, because your applications actually not call each other, not make a request. They send an event of something, and then we just handle it. And such events actually can create a whole data platform for you, whole data stack for you. And this is like two main cases when you can use Spark, Kafka at most shiny, when you have real-time streams of data, like messages from outside of the world, from different variety sources, for example, like logs on your machines, clicks of users, events from actual devices involved with IoT devices. So if you talk about the Spark controllers, this is usually a much more powerful tool. And based on our expertise, some use cases that can be most prominent for Spark. And when we have one customer that tried to unify batch, and they already had in place a huge batch processing with log processing on the streets, for example. This was like logs processing for street. We just use a lot of they use a lot of batch processing work, and this batch processing the business start to need more fresh data, and they want to speed up this batch processing. They come with a 5 minutes delay, but it was most of the current technology stack. They have a lot of code already written, and they just adapted for Spark streaming and start utilizing the streaming capabilities of Spark with the same code, with a slight modification. Well, it was a slight modification, but not completely written of the code. And this actually enabled them to have a delay of data, not in a matter of minutes before the implementing of Spark streaming, but in a matter of seconds. The delay for event was usually like between 1 and 5 seconds. Another great use case of a Spark is real-time machine learning fitting. So they have a machine learning model already educated, already built it, but they want to do some real-time adjustment to this. They use Spark. Streaming for machine learning fitting. They just re-educate the model once in a while. Once they add new events, they do some joins of streams and put this data into machine learning library that they used and just reiterate the teaching cycle. Another good example is a complex streaming processing, which is usually comes with a whole ton of different streams, different queries, etc. In this case, Spark can help you to structurize your application, structurize your data platform, because it's give you not just application, it just give you approach how to handle it. That's basically our main use cases of both Kafka and Spark. As you can see, in a Kafka scenarios, they usually shines if you have a very narrowed down use case. In this case, Kafka shines most. It's easy to acquire, easy to maintain, easy to start with, and easy to evolve. In a Spark world, usually you have much more complex stuff. If you have this complexity of your application, then you have to deal with something also complex, and Spark here is a tool for helping you. We all here made this webinar to show you how you can utilize DoubleCloud here. We at DoubleCloud have a huge expertise of helping people to build their own data platform on top of existing technologies. We actually have insert a Kafka, managed Kafka, which with a pair of a ClickHouse visualization and a transfer can actually solve a lot of use cases for data analytics. And this is also a cloud agnostic tool, so you can actually run these pipelines of Kafka, ClickHouse, Warehouse on your own region, in your own AWS account, in your own GCP account. And this actually allows you to build a very significant and complex data platform without going to the Spark line. We actually usually see the Spark as the next step for customers that have a bigger and much more complex data stacks, data platforms. But usually Kafka is more than enough, especially if it's in pair with some real-time analytical DB, such as a ClickHouse. So we can you can try us. We can send you a link to a Slack and our LinkedIn page, so you can check it out and contact us. And if you have any questions, feel free to ask. I think, yeah, I think we can jump to the question. If you have any questions, let's. Okay, I see one question about Kafka and Spark cost efficiency. Well, terminal for cost efficiency is a very complex one. We need to understand that these tools have a different cost curve. For example, a Spark has a higher onboard cost because acquiring a Spark cluster usually comes with a price. Even the smallest cluster which do nothing cost some decent amount of money. I actually didn't see any reasonable production cluster without workloads that cost less than a couple $1,000s in a month, which is decent for clusters that do nothing. On the contrary, Kafka has a lot less onboarding cost, but you need to understand that Kafka is act more like a database itself. So it's not pay-as-you-go approach. You just create a cluster on certain size and you try to utilize this cluster. In a Spark, you start to do some work, with Spark will spawn for you virtual machines that will handle this workload. And once this workload ended, these machines would be shut down. In this case, each query will cost you a different amount of money. In the Kafka world, you just set up a cluster and start using it. And this more or less constant costs, but this cost usually less than Spark. I would say in a degree of data, once you have less than 1 GB per second of incoming traffic, Kafka would be less expensive than a Spark. After that, Spark may be even less expensive option. So if you have a traffic incoming into your streaming platform approximately 1 GB per second, maybe Spark would be a cheaper option. In any other cases, Kafka would be a cheaper one. It's a good question about DoubleCloud. DoubleCloud is a provider that is built on top of existing infrastructure, the GCP, Azure, and AWS. It's a cloud software. We actually provide several services. First of all, it's managed databases like a ClickHouse as a service, Kafka as a service, and some managed service for data ingestion, transfer, and data visualization. It's actually a cloud software for building a data platform. Anything else? Any new questions? Anything? I don't see any questions. If there is no more questions, I think we can wrap it up. Oh, it's a QA section. Oh, wait a second. Where is the QA section? I written the webinar chat. Sorry. Okay. Is it possible to work with a Spark with a smaller team? Well, my answer would be here is yes, but I would not recommend to do so, because Spark is a very complex software, and having a small team here can be a bottleneck. We actually have some use cases of real customers that have a rather small data teams that try to acquire Spark, try to build a Spark ecosystem, and they actually always behind the schedule, because Spark usually comes with a complexity. And if you have a small team, like 3 to 5 engineers, maybe Spark is a not good option to you because it's too small for them. In this case, Spark can be not a good thing for you. Is there any alternative to a Kafka or Spark? Actually, there is plenty of alternative for Kafka and Spark. For Spark, the obvious alternative is some cloud native tools, or some other some other execution engine like Apache Flink can be used as a Spark alternative. Maybe Hadoop also can be used as a Spark alternative. And actually, I saw it in the wild world of internet, some people actually use Kubernetes as alternative to Spark. So just you to compare this as a scalable system of a Spark. But for Kafka, it's much easier. There is a lot of messaging bus out the road, like AWS Kinesis, Google PubSub, and Azure Event Hub. All these three is cloud native alternative for Kafka. They have a little bit less capabilities in terms of integration. They have now such huge variety of tools already in place, but they do pretty much the same job. In terms of open source, there is a lot of smaller projects that try to do the same thing as a Kafka. Out of my mind, I would say Apache Pulsar is a good option, which comes from Facebook. All this open source option usually comes with a less significant amount of libraries that already do the job for you. So yeah, there is an alternative, but it's more or less Spark and Kafka. It's more or less standard way to do the streaming nowadays. Oh, it's a good question. What does double means in DoubleCloud? Okay. It's actually a funny story behind of this. Our CTO and a friend of mine that we actually, when we started this company, we tried to come up with a name, and he used a nickname in all his internet world, which is Double. And we decided that it would be funny to name the company as it is, because we try to do this a double as fast as possible in double way, and DoubleCloud, because we have several clouds under the knees. We start with two clouds, GCP and AWS. That's a double. And same in other worlds, in the world of security, we try to do as much as possible and a little bit, even a little bit more. In terms of scale, we try to do as much as possible a little bit more. This is actually our life goal, our life approach. Do something and make it double efforts here to make it even better. Okay. This was answered. This also, and yep. And this is also. I don't see any new questions here in the webinar Q&A. So if no questions anymore, I think we can wrap it out. And thanks everyone for attending the meeting. Just check it out, our Slack and LinkedIn. And if you want to build your own data platform, you can try it with us. We have a very nice toolkit for you, and it's rather easy to acquire. Just try us and use our trials. Create your own Kafka cluster and try to play with it. And thanks for your attendance, and see you on next webinars. Bye, guys.